Hello everybody, this is Leslie Pelch at the Vermont Center for Geographic Information. Welcome to our webinar, Tips on Working with Raster Data in ArcGIS. Before I hand things over to our presenter today, I'm just going to do my quick overview on how to use the interface, and just so that we're all on the same page. So let's see if this will start up for me. Okay. So the basic things that you need to know about using your GoToWebinar panel, if just in case any of you haven't used it before, are that you can open and close the panel itself. In other words, you can get it out of the way if it's open right now by clicking on this little orange button with an arrow in it. And then anytime it's collapsed and you want to get it back, you just click on that again, open it up. If you're having any issues with your audio, you want to open up the audio panel. You'll notice the little plus signs next to things that mean you can click on it to open up that section, and make sure your settings are correct for what you're using. If you need to call in, don't use the number that's here, use the number that's actually in your panel, but that will give you the correct number to call in. As you have questions throughout the webinar, you should feel free to type those questions into your question panel, and those will go directly to me, and I will be kind of the gatekeeper of those questions. So you don't have to worry about interrupting Jarlath. Just send them when they occur to you, and I'll take a look at them, and if they seem like ones that require interrupting him to answer them, I'll go ahead and do that, and otherwise we'll probably save most of them till the end, and you can address them then. So like I said, we'll probably save the Q&A mostly for the end. The other thing is that this webinar will be recorded, and it will be posted at, this is what happens, I get frozen, I can't get out. It will be posted at VCGI's YouTube page, which you can access both from our web page, just right at the front of our page over on the left. If you look down towards the below my name, you'll see a link to our YouTube page. Also on our page, if you know where the listing, the archive, event archive is, there will be a link to the YouTube page from there. And that will probably happen within the next few days or early next week at the latest. So I think that's all I wanted to do, except for one final thing to make sure that most of you can hear me. Since I see a little list of your names, if you could all click on this button that looks like an orange hand with a green arrow on it, that's my way of knowing that you can hear me, because you're sort of raising your hand to say, yep, we can all hear you. Okay, good. As long as I see a fair number of those, I know that I didn't forget to turn my voice on or something. Thank you. And I think I'm going to hand it over to Jarlath O'Neill Dunn, the director of the Spatial Analysis Lab up at UVM, and our presenter today. You all set, Jarlath?
I am, Leslie. Thanks so much.
Okay.
Great. So thanks for joining, everyone. This is sort of a rescheduled broadcast of the webinar. Unfortunately, due to our originally scheduled time, a small person in my household gave me the flu, so I wasn't in a good condition to join all of you. But the purpose of this webinar was for me to just take some time and go over, I think, some of the most common workflow issues of working with raster data in ArcGIS, either things that people don't fully understand or capabilities that they haven't been introduced to. So what we're going to do is we're going to walk through some live demos here. We're going to go over clipping raster data, mosaicing raster data, how you can generate compressed data sets, particularly from your imagery within ArcGIS, and then doing things to improve your understanding of your raster data, things like hillshades, vegetation indices, and spatial filters. And then if we have time at the end, we'll wrap things up with some tips and tricks on projecting raster data, specifically selecting the correct resampling algorithm. So this webinar is really designed for those of you that are working with ArcGIS and you're dealing with raster data and you're sort of beginner to intermediate users. I think those of you that are advanced users probably know a lot of these things, but maybe you'll pick up some new tips along the way. So like I said, we're going to go live here, and what we're going to start off doing is working in ArcGIS here, And we're going to do a clip operation, and I want to show you two different ways of doing a clip operation. One is what I call sort of a virtual clip using the new image analysis tools that I think were either introduced in ArcGIS 10.1 or 10.2, and then clipping using a polygon layer. Okay, and just so you know here, if you see something I'm doing and you find you're not able to do it, that's because I'm working in ArcGIS 10.2.1, so if you're using a previous version, especially 9 or 10.0, things are going to look a lot different. If you're using 10.1, things are just going to look a little bit different. So I've loaded in some imagery here. This is actually some old Icono satellite imagery we've had kicking around. This is the Mad River down here. And I'm going to go into the properties here and just adjust the symbology. So whether you're working with something like ArcGIS satellite imagery or you're working with some of the new Vermont ortho photos, you've got more than 3 bands. So it's important that you understand band display. And the way to make a color infrared composite from this particular Iconos imagery is to do a red, green, blue 432. Okay, and we've got some videos on the Letters from the Sal blog that go over imagery display capabilities. So that's the adjustment I'm going to do first. And let's say I'm interested in just clipping out a small section here. So I'm going to zoom in. This is 4-meter resolution data, which is why when we zoom in, it doesn't look super clear. Okay, there's nothing wrong with the data. That's just the limitations on the satellite. Now the way to clip this data, doing this virtual clip, and this virtual clip, what it does is it creates a new raster layer, sort of in memory, if you will, from whatever you see in your display view. And this is done using the new image analysis tools. Okay, and so that's this window here. So once again, to access these tools, you're going to go to Windows, Image Analysis, and it's going to pop up this toolbar, and you can see here I have it docked on the side of my screen. Okay? So the way to do the clip, and you'll see this is true with also other operations, how to use the new image analysis functionality, is first you have to make sure that you select the layer. A lot of people think you have to have it checked. The check just turns it on and off, but you have to select the raster layer you're interested in processing. And then down under the processing toolbar here, you see there's a little icon with scissors next to a grid. That is the clip tool. Okay, when you run that, it actually generates a clip, and it doesn't matter how big your clip is, but it generates that clip in a matter of seconds. Okay, so these new tools that you're seeing here in the image analysis toolbar, they're doing all of this stuff in memory, if you will. These are all these virtual operations. A permanent raster layer is not generated. As a result, it's super, super, super fast. So these are great ways if you want to work quickly with your raster data. So you can see here I have my clipped layer. It showed up here by default, and then you have the larger satellite image layer. Now what you might want to do is you might want to export this clip so that you do have a permanent raster data set, because if you shut down your computer and you don't save this ArcMap document, this layer is gone. The same is true if you want to share the data with someone. There's no way to do that unless you right-click here, go to Data, and then Export Data. Okay, so this is a way to export your clipped virtual raster to a new raster format. Okay, and you can choose from the options here, TIFF, Imagine, JPEG 2000, etc. Okay, so that's using the image analysis tools, and we're going to come back to those later in the webinar to cover some additional functionality with them. So now let's look at another operation in clipping your raster data. I'm going to go over to our catalog here, and I'm going to add in a shapefile called AOI, and this is short for Area of Interest. So I'll do a quick adjustment of my symbology here, and what you'll notice here is I've got a rectangular polygon. And what I'd like to do is I'd like to be able to clip my raster data to this polygon. I'm sorry, just a second here. I just need to get my GoToMeeting toolbar just down lower so I can access the things on the left. Hang on just a second. Okay, there we go. So in order to clip a raster data set using a polygon, there's actually a bunch of different ways, but in the latest version of ArcGIS, it's actually helpful if you go to Data Management Tools, go to Raster, and go down to Raster Processing, and there is this clip functionality here. Okay, so this is the new clip tool that they've introduced. And the way it works is you simply just drag and drop your input raster data set here. It could be imagery. It could be a DEM. Okay, and then you can add in your output extent. Now your extent specified here is going to be determined by the polygon here. Okay, so this is just determining the extent right here using this polygon. But if I want to actually clip it down to those borders, not just the sort of bounding box surrounding those, I have to click on this here. Okay, this is the Use Input Features for Clipping Geometry. This will actually nail it down. And then I'm just going to specify the output location here. So under Clip, I'll call this just Clip. And when you're creating output raster data sets, you have the option of having no extension. This defaults to the grid format. Okay, there's nothing particularly wrong with grid, but it is a clunky format, and the folks even at Esri will recommend against you using it anymore. I've had best success using the ERDAS Imagine format, so I always type .img at the end of all my rasters, especially if you're working with image data sets. That'll have the best result there. Okay, so then you can go ahead here and run this operation, and this is executing a geoprocessing tool. As a result, it's going to take substantially longer than if you were using the image analysis tools here. Okay, and you can see if you go to your results tab here how long it took. And we're working with a pretty small clip here, so things went pretty quickly, but it's not instantaneous like it was with the image analysis tools. And of course, we can go here and simply import our symbology from our other layer if we so choose, and then we're ready to go, and we've cut things down here. And actually, sometimes things look a little bit funny if you have, oh, something definitely went funny here. I think we've got, let me see. Well, this is the fun of live demos. Oh, wait, sorry. Sometimes if we take off the, there we go. Yeah, so if you run into funny issues after you're clipping your data, remove this apply gamma stretch thing right there. That sometimes makes the imagery go funny. ArcGIS will default to that by itself. Okay, so that's a way to clip a raster data set using a polygon layer. Okay, so we looked at two ways to clip the raster data set there. First, using the image analysis tools, we went down to the sort of virtual clipping tool. And then the second way with our toolbox was using the clip tool. All right, so let's go ahead, and we're just going to switch over here. I'm just going to put you on pause a second while I start up a new session. Okay, so in this next session, what we're going to do is we're going to look at mosaicing data. Okay, and so mosaicing is the process of taking adjacent or overlapping raster data sets and producing a brand new contiguous raster data set. So I'm going to load some data in from our catalog. It's actually the same imagery that we just had, except it's divided into two sections. So I've got a north section here, and I've got a south section. And I'll zoom to full extent. And so what you'll notice is that these two layers here have some overlap associated with them. We can go ahead and adjust the symbology like we did before. If we want to make a true color composite this time, we can do a 3-2-1 band combination and then transfer that over to the other layer. Okay, so we've got two image data sets here, and they overlap a little bit. And our goal is going to be to take these two data sets and create a brand new seamless raster. In order to do that, we can go over to our toolbox and go down to Data Management Tools and scroll down here to Raster, and we can go down to Raster Dataset Toolset, and we can run this tool here called Mosaic to New Raster. Okay, so what the Mosaic to New Raster tool will do is it'll take two or more rasters as inputs, and it's going to create a new seamless raster data set. Okay, so let's go ahead and add those. And I apologize if you're seeing some flickering on the screen. Seems like GoToMeeting causes some strange refresh things today, but hopefully that doesn't interrupt you too much. I'll see if I can't take a second to resolve that. I'll simply specify the output location here. This is the output workspace. I'll call this output dataset mosaic. I'll put the .img extension. Now it is very important you pay attention to these settings down here. ArcGIS is not very intelligent when it comes to mosaicing. So in this case, I have 16-bit unsigned data, and so I need to specify the pixel type. Otherwise, it's going to adjust the pixel type for me and chop off data sets. I also have to specify the number of bands, or I could lose bands, and I have 4 bands in this case. Finally, the last thing that you want to specify is the mosaic operator. The mosaic operator is only important in those cases where you have overlapping imagery or overlapping data. In this case, I do, and I'm going to choose a blend operation. A blend operation will sort of mix the two values there to come up with sort of a best of both worlds, and hopefully we won't see any seam lines when we run this mosaic process. Okay, so once again, you can load in as many rasters as you want. Just specify the output. Make sure you know something about your data first by checking out your raster dataset properties to ensure these settings are correct, and then you can click OK to run the operation. As with our clip operation, this is an actual geoprocessing tool, so as a result, it runs rather slowly. Okay? So here we go. And Leslie says she hasn't noticed flickering, so that's good news. Maybe it's just on my end. So what we've got here is a new output mosaic. I'll just import the symbology from one of my previous ones. And you can see here now we have a seamless mosaic. And what's really nice is even down in this area here where the two images overlap, we don't have any noticeable seam lines due to that blending operation. Okay, so the Mosaic to New Raster tool will allow you to take 2 or more individual raster datasets. They can either be tiled raster datasets or overlapping raster datasets, and they will create a new raster. Now, in this case, I created my output raster in Imagine format. So this is an uncompressed format. It's rather large. Some of you, especially if you've been working with the Raman ortho photos, have become familiar with compressed formats such as JPEG 2000. So if I wanted to share this image mosaic with colleagues, and I'm emailing around or posting it to an FTP site, it might behoove me to first do a little bit in terms of image compression. So if you want to take advantage of image compression in ArcGIS, one of the easiest ways to do that is with your data loaded into ArcMap, simply right-click and go to Data and go to Export Data. Under the format here, the best option you're going to want to select is JP2 for JPEG 2000. JPEG 2000 is an open format. It's what VCGI uses to run the compression on the Vermont ortho photos, and it's really become the industry standard. So that's your first thing. You want to select JPEG 2000. You want to make sure you have the output folder there. You want to specify the file name. We'll just call it comp for compressed. And then here you can specify the compression quality. Okay, obviously closer to 100 equals better quality, but lower compression. Okay, so here I'm going to change the value to 50. So a compression value of 50 means that I'm going to get pretty good compression on this image data set, but my quality is going to suffer some. And you might ask the question, well, what compression quality setting should I use? And that is really a lot of trial and error with your data set. So I often recommend to people, clip out a small portion, play around with some different compression quality settings, see what you get in terms of file size settings, and then see what you're happy with. Okay, so we're going to click Save there. Actually, let's just cancel that. Oops, sorry. I didn't actually want to cancel that. I just didn't want to overwrite my existing one. Let me just specify a different location for this. Let's put it in. We'll put it in clip here. Sorry about that, folks. We'll go back and set 50 here, and then we'll call it compressed again. Okay. All right, so here we have a new data set. We'll go ahead, we can import the symbology settings from Mosaic and be happy with that. So now we can do a little bit of exploration here, and if we open Windows Explorer, we've got way too many different directories here in Drives map. But if we go into the VCGI webinar folder here, we see that the original Mosaic, oops, wherever I put it, is going to be substantially, this one's going to be substantially smaller. Okay, so we get a compressed imagery here, this file of less than 2 megs, okay, and the original one was 5 megs. So you can see here that we have a savings of more than 50% by going to JPEG 2000 format. And that can be substantial if you have some very large data sets. So just to recap for compression, you're going to right-click on the data set that you want to compress, go to Data, Export Data, change the format to JPEG 2000, adjust the compression quality settings, make sure that you're happy with where it's going, export it, and it's going to produce a new data set in JPEG 2000 format. All right, so I'm just going to start up a new ArcMap session here, and we're going to switch over from working with imagery to loading in some LiDAR data and looking at how we can take advantage of some of these image analysis tools to do some virtual hill shading. So a lot of you in the past, when you ran a hill shade operation, you probably did it using the spatial analyst tools, right? So now we've got a new ArcMap session here. Let's just load in my data first. I'm going to load in a DEM here. Okay, this is actually from the Missisquoi LiDAR collect. We'll do a little bit of symbology of this in a second. But if you did hill shade operations before, you went to spatial analyst tools, and then you went down to surface operations, and then you went to hill shade, and you ran this tool. And what this hill shade tool does, it is actually generates a new raster. And there's nothing wrong with using this hill shade tool. But when you're going to start running hill shades on some of the giant LiDAR data sets that we're working with VCGI to get to you folks, this thing's going to take hours, if not days, and your output raster is going to be massive, hundreds of gigabytes. So this isn't something that you really want to hang around for, especially when all you're looking for is a nice visualization. So let's say we want to create a shaded relief graphic or map from this LiDAR data set. So first thing we might want to do is just go into our symbology and our layer properties and apply a nice little color ramp. We'll use the standard color ramp here. Maybe we want to do a min-max stretch or something like that to our DEM here. We see a nice gradient here going from east to west where the topography increases. Now to do our hill shade, we're going to once again use the image analysis tools. Okay, so if your image analysis toolbar is not displayed on the right-hand side like mine is, you go to Windows and scroll down to Image Analysis. Now in the Image Analysis window here, I click on the raster layer I wish to process, and I'm sorry, I just got to scroll my GoToMeeting toolbar out of the way here. You scroll down to this little button here, which is the shaded relief. And next to shaded relief, you'll notice that you have a color ramp. So I can create a shaded relief using the default color ramp, okay, which is this one here. And that actually produces a new shaded relief composite. I'm going to just remove that. The other option, and the one I typically prefer, is actually to go and generate a white to black shaded relief, such as you see here. So it added that shaded relief automatically. Sometimes I just like to look at them without color. And then if I want to create that nice shaded relief look, I can just put it below my existing raster data set, go to the Display tab, and adjust the transparency to, say, somewhere between 30 and 40%. And that also creates that shaded relief look. Okay, you'll notice that when I ran that hill shade tool, or the shaded relief tool in image analysis, it ran in seconds, okay? And this is not a small data set. This may look like a small area, but if we look at the size of this DEM, it's actually pretty sizable, okay? It's 6 megs and it's got, 1300 by 1300, okay? This is going to take at least several seconds, and if we were to run the whole Missisquoi watershed DEM, this is going to take, as I mentioned before, many hours. So simply select the layer that you wish to run the operation from, choose your shaded relief color ramp, and click on the shaded relief tool, and you'll have a new hill shade layer that's available to you in seconds. Now once again, this layer is a virtual layer, and if you right-click and go to the properties of it, you can tell it's a virtual layer because it's stored in a temporary location. Okay, so this is my temporary location where I'm storing this raster. All right, so a little tip there on using hill shades. We're going to keep with this theme of using the image analysis toolbar, and I'm going to go here and just put you on pause for a second while I load in another new map, and we're going to look at doing some indices, okay, some spectral processing on the data. And I think Leslie sent this out a little while ago. She was wondering if someone had any thoughts on what to do regarding working with near-infrared imagery and things like that, okay? So coming back and turning on my screen here, we're going to go back to this Iconos image that we had before. Okay, this is a 4-band image, meaning that it senses not only visible light, and we can do that by creating a natural color composite to take a look at it. That's a visible wavelengths right there. It also senses the near-infrared wavelengths. So the near-infrared wavelengths, as many of you know, just out beyond visible, very useful for vegetation. Okay. And the Vermont ortho photos also have a near-infrared band associated with them, although if you want to create a near-infrared composite, the band combinations actually are 412 in those cases. So you can see here when we display that band 4, that near-infrared band, the vegetation really jumps out at us. And there's a neat ratio called the Normalized Difference Vegetation Index, or NDVI, which is essentially a ratio of near-infrared light minus the red light divided by the near-infrared light plus the red light, okay, NDVI. And there's some great online reading materials if you just do a nice little Google search for that. Now to calculate NDVI in ArcGIS, you could of course go into the Raster calculator and plug this formula in for each band, but there's a much easier way using the image analysis tools.
Hey,
So
Jarlath?
yes.
I think we are not. Yeah, there we go.
Sorry
Thank you.
about that.
That's okay.
I forgot to unpause. Okay,
That's okay.
So just to recap here, we're looking at a color infrared composite of this image. So the easy way to generate NDVI, or the Normalized Difference Vegetation Index, within ArcGIS is to go to your image analysis tools, select the layer that you wish to process, and once again, it has to be a image data set that has the near-infrared and red bands. Okay, this won't work on the old black and white Vermont ortho photos. Okay, and then you're going to go down to this little leaf icon here, NDVI. Okay, and it's going to run NDVI automatically for you and do that virtually. So you can have some very, very, very large data sets to process NDVI, right? You could have a giant mosaic of Landsat imagery or Vermont ortho photos, what have you, and you can generate NDVI pretty quickly. Now, NDVI values typically go from -1, meaning no vegetation content, to 1, very high vegetation content. ArcGIS does not do that automatically. It produces an NDVI layer with values from 0 to 255, or 8-bit data. So to get the -1 to 1 option, you have to go into the image analysis options and click on NDVI and check this one here for scientific output. Okay. Prior to running NDVI, you're also going to make sure that you want to confirm which is your near-infrared band and which is your red band. So this is where you have to go in and pay attention to your image metadata. So in the case of Iconos imagery or QuickBird imagery, the settings are going to be 3 for the red band, 4 for the infrared band. If you're using the Vermont ortho photos, it's going to be 1 for the red band and 4 for the infrared band. This is once again the new Vermont ortho photos that are 4-band. If you're using NAPE, it would also be 1 and 4. Okay, so you just have to understand which bands correspond to which wavelengths. And this is a good chance here for us to use things, right, like transparency. We could go back and forth. We can flick these layers back and forth. We can see that NDVI does a really good job here in showing us things that are vegetation. Those with the white are very, very high values versus things that have no vegetated content. The river, the impervious features, and those agricultural areas, such as this field here, that don't have any vegetation on them right now. Okay, so NDVI, quick and easy way to do that. Once again, it's a virtual layer, so if I want to make something I can share with others, I'm going to go to Data and Export Data. Okay, so the Normalized Difference Vegetation Index, really handy for that sort of stuff. We're getting close to wrapping things up here. Let's go back to our image analysis toolbar and look at some of the other functionality we have using filters. Okay, so filters might help you improve your imagery make it more interpretable, and see different features. So that is down here. Once again, you have to select the layer you wish to process, and you can run things like sharpening filters. You see the layers created instantaneously, and a whole host of very strange things like horizontal line filters. Okay, so these are things where to play around with them in the past, it used to take a lot of time to run these. And these may not be always useful to you, but they can help highlight certain features on the landscape when you run these things, especially as you get into feature extraction and mapping things. And the nice thing about the image analysis tools nowadays is you no longer have to run these and wait hours for processing. So you can really play around with these types of things and get results instantaneously. So the last topic that I wanted to cover where people really make mistakes is when they project raster data. So I'm going to just start up a new ArcMap session here. Okay, and we're going to go over and add in some imagery. So let's see, let's go down here. I'm going to grab some imagery here. This is actually WorldView 2 satellite imagery, so it's got 8 bands. Here we are looking at the Burlington International Airport, and it's 8 bands here, so I've really got to pay attention when I generate this multi-band composite so that it's something that looks good, okay, and read up on all those bands on the sensor website. So here we have the imagery there, and let's say we want to go ahead and take this particular data set right now and get it in a new coordinate system. Well, if we go into the properties here and go into the source tab, we can see as we scroll down that the current coordinate system is Vermont State Plane Nat 83 meters. Now I'm going to go into our toolbox under the data management tools under projections and transformations and go down and run the project raster tool. You should only run the project raster tool if your raster dataset has a defined coordinate system. So the project raster tool is going to ask you a few things. First, it's going to ask you for your input raster dataset, and then your output raster dataset. And I'm going to call this one imagery_nn.img because we're going to use nearest neighbor resampling, which I'll talk about in a minute. So here I've specified my input raster and my output raster. Now I have to specify the output coordinate system. It knows the input coordinate system because that's been defined. And for this example, I'm just going to choose Albers conical equal area. A geographic transformation is only necessary if I'm switching datums. Now what's very important is this thing here, the resampling technique. And ArcGIS gives you 4 options. Nearest neighbor. Nearest neighbor simply takes the cell value that's closest to it. Now, why does it need to do this with raster data and not with vector data? It's because pixels are squares, so they cannot be stretched and pulled around like polygons can, or just stretched like lines, or just change their individual location like points. So you have to do this process known as resampling. Bilinear takes a weighted average of the 4 surrounding cells. Cubic, a weighted average of the 16 rounding cells. A majority takes a majority based on the surrounding cells. So when should you use these? If you have continuous data, such as imagery or elevation data, you probably want to use cubic convolution. Okay? If you have thematic data, such as a land cover data set, something with discrete values in which each pixel code corresponds to some sort of phenomenon, like a land cover class, and not a measured value, like elevation or spectral response, then you want to use either nearest neighbor or majority. So I want to show you how this looks, this image data set, when we project it using nearest neighbor. And then I'm going to repeat this operation using cubic convolution so you can see the differences. So one of the nice ways to rerun your tools is simply to go into the Results tab here. You can see what I ran, and I can open up my tool again. All the settings are going to be there, with the exception in this case, I'm going to call it CC for cubic convolution, and I'm going to rerun this again using the cubic convolution resampling technique. Okay, and then I'm just going to go ahead and import my symbology very quickly here to make sure that everything looks the same as before. Okay, and then we're going to do a quick comparison here. So let's start by unchecking these, display the original imagery, and we're going to move into the lines on the airport here. This is the original image, okay? This is the cubic convolution one when I flick that on here. And sorry, I forgot to import the symbology here, so let's get that straightened out. There we go. So you're going to notice that when I turn on this layer, compared to the original one, the lines appear very jagged. Okay, so nearest neighbor is very good at preserving the true original pixel values, but it really distorts the data spatially. So when you're working with high-resolution imagery or digital elevation models, where it's not only the individual pixel values, but their values relative to one another that matter, nearest neighbor is generally a poor choice because it does things like this, right? It really makes those lines jagged, as opposed to if we do cubic convolution, which is what you see me displaying over the nearest neighbor one, things seem a lot smoother, okay? Now, things are going to be different. If I, for example, remove these quickly, okay, and I quickly load in a land cover data set. Okay, so here I have a land cover data set with 7 land cover classes, actually for the exact same area here. If I go and run the Project Raster tool, and I use cubic convolution, okay, instead of either the ones I should, which are nearest neighbor or majority, it's going to cause a lot of problems here because it's taking a weighted average of the surrounding cells. Okay, so I'm going to call this land cover underscore cc.img. Okay, so we're running a land cover projection, Project Raster tool using cubic convolution. All right, so we're going to go ahead and run this. We're going to show you what goes wrong here. It's actually going to create some new values here. And to see those new values, I'm going to go in to my raster properties here and run the build raster attribute table tool. So this is something you should do every time you generate a new raster with discrete or thematic data here. And what you're going to notice is that if I go into the attribute table now, I have a new value, a value of 8, which I didn't have before. And I won't display that automatically unless I go here and click Add All Values. So because it's taking this weighted average of the surrounding cells, with the cubic convolution, I have all these really, really nasty edge effects here. So flipping back and forth here between the two, you can see how the cubic convolution actually introduced new values and new land cover features that were not there before because it's taking a weighted average. So that weighted average approach using cubic convolution works really, really well, once again, with imagery and elevation models where we want to keep things smooth and preserve the spatial patterns. It doesn't work at all with discrete raster data, such as thematic land cover data sets, because it's going to introduce errors and actually introduce new land cover features. Okay, so the takeaway home message from this is that if I were to reproject this land cover raster data set, I'd want to choose a resampling technique of either nearest neighbor or majority, okay, because it's not going to invent new cell values. So just coming back to our little PowerPoint here, what we did today, we showed you clip operations, both the virtual clip operations using the image analysis tool and polygon clip operations using the clip raster tool. We showed you how to mosaic to a new raster, so taking raster data sets, stitching them together, maybe they overlap or they're just adjacent. Showed you how in ArcMap, if you right-click on your raster data set and go to Data Export Data, you can export in a compressed format to save disk space. Showed you also how to use the image analysis tools for a bunch of other functions. For example, creating a virtual hillshade, very useful when working with large complex LiDAR data sets. Generating things like NDVI, the normalized difference vegetation index from imagery, and also playing around with things like spatial filters. And then finally, we gave you some tips and tricks on projecting raster data. Okay, specifically we said that if you've got some type of continuous raster data, such as a digital elevation model or imagery, you'll want to use cubic convolution. Okay, if you have other data, such as discrete thematic data, you're going to want to use something like nearest neighbor or majority will work just fine. Okay, and finally, I'll just bring up my my YouTube channel here. So I think I sent this out to the VCGI list, but I may not have. I probably need to resend it. But what I've done here is I've taken a host of videos, both ones that I've created. There's about a dozen or so here, And there's also another 15 or so that have been put together by other people on the web, and I've compiled them into a geospatial videos playlist. So you'll find a lot of these topics that we covered today recorded and narrated with a lot more in-depth discussion on this YouTube channel. So clipping imagery in ArcGIS, image mosaics and compression, all those sorts of things, coordinate systems and projecting rasters. So these are on my little YouTube channel here, and it's called the, what's it called? It's called the Geospatial Videos playlist. So I'll make sure that I send this out again to the VCGI listserv. And with that, Leslie, I think I'm ready for any questions.
Okay, and I'll also post the link to your YouTube channel in our event archive below this this webinar listing.
Great, thanks.
So I'm going to use my power right now to ask the first question, because I have a really simple question that came up the other day when someone called because they were having an issue bringing an orthophoto into ArcMap. And if you were to go into the properties of the image where you change the bands, set the bands to the different colors, I figured out that his problem is, for some reason, his was set to the stretching option rather than RGB composite. But the strange thing was that as I was looking up the help on it, I noticed that ArcMap seemed to be saying there should be 4 or 5 different options there, not just those 2. And I noticed that on mine, there were only those 2. And as he was looking at it, he did not have RGB composite there, and he had version 9.3 or something. So I was just trying to figure out why ArcMap was telling me there should be like 4 different options in there. I was only seeing 2, and then he wasn't even getting the normal one, which is the RGB composite, as an option. And that was just a little, I don't know if it's worth asking this here, but since you went into the properties for the image,
yeah.
You know, that's a part of what you do when you're setting things for the image.
Yeah, so let's take a look. So I've just loaded in actually one of the new Vermont Ortho photos here. Mm-hmm. And the first thing to determine why you might not be seeing those things is right-click and go into the properties. Mm-hmm. Okay? And under the source tab here, if you see under number of bands, if you only see one, mm-hmm. if you see one band there, it's not going to give you any other options under symbology. It's not going to give you RGB composite. So it's very important that if you want RGB composite, that you have something with more than one band. So typically, right. You're going to have 3-band or 4-band imagery. Right. So that's the only thing that I can think of, is that he had some sort of one single band imagery in there, and he was trying to display it as color. I've seen people do this all the time. They grab the old Vermont black and white orthos, and they're like, how do I display these as color? They're only one band.
Kind of like, how do I get it to be higher resolution?
Yeah. Enhance. Yeah, I'm guessing that was the issue.
So under show there, stretched and RGB composite, those are sort of the default 2 that you would see there. Why is it that when I looked in the help, it told me there were going to be like 4 or 5 different options under show?
Yeah, you will have other options depending on your type of data. So if I have land cover data in here, so if we go back, and I can go back and let's see, quickly start loading that land cover data set we were working with. Let's see, that was the project one here. I'll just load it into this ArcMap session. So if we go into this one here, mm-hmm. and look at the symbology here, now you see 4. The reason why is this is what
different type of data.
It's a thematic raster data set in which the pixels each mean something, and I built a raster attribute table. Okay. So this is why it's different. So ArcGIS is generally pretty smart about what kind of raster data you have. Okay, great. Thank you very much.
So Jonathan had a question early on that I think I knew the answer to, but I want to make sure. And he asked whether we can do, back when you were doing the clip, whether he can do a clip from a VCGI map service. And my answer was no, you can't, because what we're offering is not a feature service, it's just the map service.
Yeah, I've never tried to do that. There are some services that allow you to do a clip, but in this, I'm pretty sure you're correct, Leslie, that it's just sort of like a web map service. So there's no actual the data is just kind of being streamed in there as tiles, so it won't allow you to do a clip as if you had the data locally.
Okay. And Jonathan also asks, can you review which resampling options to use for which file types, which imagery types, I think?
Yeah, so generally the rule of thumb is that if you have continuous raster data, so it's measuring some phenomenon, so by that we mean it's imagery or elevation data, then you use cubic convolution resampling. Okay, that's going to be your best option. It's going to preserve the spatial properties. In the case of high-resolution imagery, it means you won't get sort of jagged edges of roads and buildings. In the cases of elevation models, cubic convolution will ensure that you have a nice, smooth raster surface and you won't get all these jagged edges that would introduce pits and things like that if you wanted to do 3D profiles or hydrologic modeling. So cubic convolution for imagery or elevation models. Then if you have land cover data, such as what you see here, nearest neighbor majority are good ones. In ArcGIS, I actually tend to favor majority. I think it makes it look a little bit cleaner.
Okay. All right. Has anybody else got questions? I'm not seeing any other questions right now. I think, let me just make sure, though. It's bigger. Okay. As usual, I think you've covered it so clearly that people are not coming up with questions.
Excellent, great. Well, I'll send out that YouTube link to the VCGI list, and
Great.
like I said, I think if you feel like you missed something here, of course, Leslie, you're going to be posting the recording, but I've got a lot of dedicated videos there that go into detail on these topics.
Okay, and actually, so one more question did come in. Why would you recommend resampling if the raw data is the, and in quotations, real data, such as land use, land cover data?
Well, that really depends. Is that if you're going to be doing a lot of analyses in another coordinate system, you may need to resample. Generally with raster data, I think the person asking the question makes sort of a good point. They don't quite get to it, but which is, yeah, you generally don't want to resample your raster data if you can avoid it, because you are creating new data. It's not the same data set. It's not like vector data. When you project vector data, you can go back and forth. You can change it to go from Vermont State Plain to Albers equal area to back to Vermont State Plain, and it's essentially the same thing. If you do that with raster data, it does not come back as the same thing. You've altered it twice. So you do want to try avoiding projecting raster data if you can, but if you're doing analysis and you're getting a bunch of national raster data sets and you've got a bunch of local raster data sets, chances are you want everything in one coordinate system.
Okay. All right, this is your last chance, everybody. We're gonna shut it down, I think. Okay. Thank you very much, Jarlath. And as everyone just heard, we will be, this webinar was recorded, and it will be posted at our YouTube site, and it will be linked from our website as well, our YouTube page. And I will also post the link to Jarlath's YouTube page that he referred to in our event archive. And if anyone has any questions, they can send them to me, and I'll make sure that you get to the right link. Thank you very much, Jarlath.
Okay, thank you, and I hope this was valuable to everyone.
Definitely. Have a good day.